Welcome to my channel Maithili SK. I am a professor at KGISL Institute of Technology, Coimbatore. In this session, I am going to explain you the topics under EC 8395 Communication Engineering, which will be beneficial to second year Computer Science Engineering students under third semester Anna University. The topics to be covered are: what is communication, types of communication, what is modulation, and what is the need for modulation. So what is the objective of today's session is, at the end of the session, those who are viewing this will be able to define communication technically, and they will be able to relate real-time scenario in communication. Imagine a world without communication. So actually, what do you mean by communication? So I am talking to you or conveying my message in the form of this YouTube channel, right? So this is one form of communication which I formally convey some messages, that is about the subject of communication engineering, through this channel, that is YouTube channel. So communication is nothing but transferring of information from one point to the another, that is here from me to you. So what are the communication forms available? So you could see here, communication is available in different forms in our day-to-day life. Imagine a world without these gadgets, appliances and tools. So what is these gadgets, appliances and tools I am trying to say is, so you are using mobile phones today and you are using some appliances, say for example ATM machines. So that is a satellite communication by means of this SATCOM, radar communication. So everything which is around our life is based on this communication. So in earlier days, how this communication is done is nothing but by means of a physical means. That is, a person used to carry information from one person to the other. So it will be written in a form of just a note, and it will be delivered from one person to the other. And through the evaluation of techniques and the technological developments, this communication has slowly and steadily entered our lives. And now we can say it has become a part of ours. So without mobile phones, it is something tedious to live apart nowadays. So technology has, we can say, it has engulfed our life to an extent. So this is about the general form of communication which you will see in our day-to-day, our life, right? So what is communication? Coming to the technical point of view, if the definition is asked, you should write, it is the process of conveying or transferring messages from one point to the another. So this one point to the another is nothing but from the source to the destination. So as in the syllabus point of view, the video, I have explained what is line of sight and non-line of sight communication. When it is a line of sight communication, the distance between the sender and the receiver, source and destination, is minimum. So it does not need any means of devices to carry the information from this person to this person, that is from source to destination. This is known as line of sight communication. Talking about non-line of sight communication, it is rather the next point. So imagine this person is in a distance which is not reachable by the destination. So here we have to pass an information from the source to the destination, so which doesn't be able to carry in just a medium. That is, if the distance is less, it is okay. If the distance is increased, it is not possible. As I said, an example, a person in Coimbatore, whom he is here, willing to communicate with a person in Chennai, it is impossible for him. Then here comes the line of sight, non-line of sight communication. This needs installation of antennas and some communication systems or devices which carry the information what this person needs to send. So coming to the basic block diagram of communication system, the system components here is basically 3. Based on the system requirements, this transmitter section and the receiver section will be added with more number of devices, that is more number of blocks based on the requirement. But this is the basic block diagram. This is also I have explained in the syllabus part or syllabus flow in the last video. So just a recap of it. It consists of 3 sections: transmitter, channel and receiver, from the source to the destination. Here it is the transmitter section, which needs a channel through it to carry the information, then it is received at the receiver. Finally it is conveyed to the destined person. In between this channel, here it is affected by means of noise. So channel also I have explained, there are 2 types of channel: wired channel and wireless channel. When it is a wireless channel, noise is enhanced. So it is a medium which is used here is the free air, that is electromagnetic spectrum. So all these scenarios we have seen in the last video. This is the basic block diagram of communication system. Coming to the types of communication system, this communication system is divided into 2 types, basically the analog communication and digital communication. Further, this combination of analog and digital can be called as hybrid communication. So the base of this analog communication, it is divided into 2 based on continuous, that is waveforms, that is signal, continuous wave modulation and pulse modulation. Further, this continuous wave modulation is divided into 3 types. One is amplitude modulation, and next one is nothing but the frequency modulation and the phase modulation. So this is mentioned as FM and PM. So this 2 is combinedly called as angle modulation. Under pulse modulation, here the carrier information is in form of pulses. So this is divided into 3 types again, that is pulse amplitude modulation, pulse width modulation and pulse position modulation. Under digital communication techniques, so digital communication techniques uses pulse code, it is divided into pulse code modulation, delta modulation, differential pulse code modulation, and further this delta modulation will be divided into adaptive delta modulation, and this PCM may be also divided into adaptive PCM or adaptive differential pulse code modulation, etc. So this is about the different types of communication system. So this is how your syllabus is framed till this 2nd unit. So you could see here, this is what we have seen here: analog modulation, this pulse modulation. So under pulse modulation you could see here PAM, PCM, DPCM, etc. This DPCM is also, you could differentiate what is the pulse modulation which is coming under PCM, DPCM, etc. It is all based on the pulse type. The carrier wave is nothing but the pulse type, hence it is a pulse modulation. What is the digital modulation techniques is? That is, digital modulation is different. So digital modulation technique is based on the digital pulses which is in the form of keying, that is zeros and ones. So it is divided into ASK, PSK and FSK. So further that is divided into BPSK or DPSK or QPSK, etc. So coming to the part modulation. So as I said, when the source to destination distance is very large and any other mode of that is communication system is involved, it requires some communication components to be included to carry that message signal from the source to the destination. This is enhanced by means of this modulation. So coming to this modulation part, talking about this non-technically, what is modulation is nothing but changing. So changing something to some form to be used. So based on the requirement, changing to some form to be used. So coming to this technical form, so how I can define modulation is, it is a process by which some characteristics of a high frequency carrier signal is varied in accordance with a message signal, right? So here when communication is considered, it depends on two types of informations. So this information is clearly called as the message signal in terms of communication, that is message signal M of T, which is a very low frequency signal. Hence it cannot be carried for a long distance range, right? In order to carry this message signal, this is the actual information signal which is to be carried from the source to the destination, right? So this message signal which is in low frequency is to be carried by means of another signal which is known as the carrier signal. So why it is called carrier signal is nothing but it will carry this message signal from one point to the another, that is source to the destination. This automatically we can say this carrier signal is nothing but a high frequency signal. So this information for an effective transmission of communication will have two important signals, that is the message signal M of T and the carrier signal C of T. So throughout this first unit you will be talking about this M of T and C of T, right? So how I can tell this modulation part now? So modulation is nothing but it is the process by which this is carrying, right? By which the characteristics. So characteristics is nothing but which can be at a signal characteristics which is to be varied, right? By which the characteristics of the carrier signal, right? Of the carrier signal is instantaneously varied. So why I am telling instantaneously varied means because it is a continuous time signal, hence it is dependent on the time factors. So time is always, when we say instant means it is dependent on time. So by which the carrier signal is instantaneously varied with respect to the which type of signal? With respect to the another signal, that is the message signal. So it is compared and based on its requirement it is carried, right? Modulation is the process by which the characteristics of the carrier signal is instantaneously varied with respect to the message signal. As I said, this types of modulation is divided into analog. Under this analog it is continuous wave. Under this continuous wave it is divided into amplitude modulation, frequency modulation and phase modulation. So this is what the flow of our syllabus is. So first half we will study about first unit, that is analog communication type, in which the continuous wave modulation is fully explained based on this amplitude modulation, frequency modulation and phase modulation. Finally it is all compared, and all these comparison will help you to analyze the differentiation between this angle, frequency and phase. So I will just give an hint of it. The process by which the characteristics of the carrier signal is instantaneously varied. So what is this characteristics in terms of amplitude modulation? Here is the amplitude characteristics. When it is a frequency modulation, it is the frequency of the carrier signal. When it is phase modulation, the process by which the phase of the carrier signal is instantaneously varied with respect to the message signal. Hence, this is how the definition for 2 marks can be written is simply. Continuing it, need for modulation. What is the need for modulation? Why we need modulation techniques? So this need for modulation is for easy transmission. So in order to enhance easy transmission of the signals from source to destination, it requires modulation. And for narrow banding, so narrow banding techniques in order to reduce the frequency content in the band, how it is carried from the source to destination. If a small frequency content is used, minimum frequency content is used, that is narrowbanding technique. Next is multiplexing. So multiplexing is nothing but, as I said, from the source to destination. This modulation is a necessary when there is an installation of antennas, that is for radiating signals we go for this antenna techniques. So it uses free air as a medium. So when this air is used as a medium, the channel is very open to all means of communication, which not only has a single signal over this channel, but it has multiple signals. So then it needs multiplexing. Multiplexing will enhance this signal transmission technique very effectively, that is from one point to the other. Next is to overcome equipment limitations. So signal processing, which uses wide range of frequency will require more equipments. So this equipments can be limited by means of implementing through this modulation technique. And further, this kind of modulation is required for this frequency assignment. So which frequency content is to be used for particular applications. This is assigned by means of this particular modulation techniques. So next is to reduce noise and interferences. As I said, if the channel is a free air, then it is interfered by means of noise. The basic block which has in the channel part a block which is nothing but noise. So in order to reduce this noise and interference also, we need this modulation. So this can be asked for your 2 marks, need for modulation. If they are asking for 2 marks, you can at least write 4 points to get complete 2 marks, or it is well and good to write all these 6 points, but not less than this 4 points. So now let me explain you one by one how this need for modulation is satisfied in each of these subcategories. So first one is for easy transmission. So as I said, for easy transmission, when the medium it uses free air, then we go for this antenna techniques, installation of antennas. So here there is a source and here there is some destination part. So this is nothing but your channel, which is a free air. So it requires initial installation of antennas. You could see, you have seen antennas in your areas, right? So this antenna is nothing but which is a very huge tower. At the top right, it will have some transceivers, that is, which is a device which transmits as well as receives the signals, which is known as transceivers. So combinedly it uses both this transmitter as well as receiver. It is one way of communication from the source to this point and from this point to the destination, as well as it can respond from the receiver to the source. So hence transceivers are initialized, that is installed at the top of the tower. So this antenna installation, it requires a huge cost. So this antenna installation requires a huge cost. So now we will see how this cost can be reduced. So if the height of the antenna is increased, then it requires more manpower, it requires more components, and it requires more time, which is which is a drawback for this communication system. So this antenna height is very important in terms of modulation, that is, determination of antenna height is very important. How this antenna height is related with the modulation technique, now let me explain. So consider a signal. Since this antenna is using air as a medium, right? So this is to be radiated in this free space in the form of signal. So this radiating frequency signal will be converted into a radio frequency signal. This audio signal, that is audio frequency signal, will be converted into radio frequency signal, which is carried by means of a carrier of high frequency from the source to the destination. So I will give you example how it is determined. This antenna height is determined by it is based on the radiating effect of the antenna. So whenever an antenna is installed, it has some radiating power. So this area will be covered by this antenna. So this is what is called as, this is the radiating power of this antenna. So this device, whatever is installed in this area, will be covered under this region. So this is the radiating power of this antenna. So this is nothing but the wavelength. So which is this antenna height is dependent on the effective radiation, which is dependent on the wavelength, which should be half of it. So the frequency, that is the height of the antenna required for effective radiation, should be half the wavelength, right? Half that of the wavelength, right? So let me explain you. This is what the formula to find the antenna height, right? So from this lambda is nothing but the wavelength of the transmitted signal, right? Transmitted signal. So this wavelength can be given by lambda is nothing but C by F. So what is this C? C is nothing but your velocity of light, and F is nothing but frequency of the signal. So how this wavelength is related with the particular signal frequency is by means of these terms. So what is C is velocity of light, what is F is frequency of the signal. So what is our antenna height formula? It is lambda by 2. So now using this equation in this, we will get antenna height is nothing but, instead of lambda I am going to substitute C by F. So it is nothing but C by 2F. So using this formula, already we know what is velocity of light. So for every transmitting signal, they will be allocating with the particular frequency. So from that we can determine what is the antenna height. So frequency is nothing but frequency of the particular transmitting signal. So coming to the example. So example 1, we will compare two types of frequency signal, how this antenna height is differentiated. So consider here a frequency of 1.5 kilohertz signal, which is a low frequency signal as far as the first example is considered, right? So for the second example, I am going to consider the frequency 2, this frequency 1, which is 1.5 megahertz. So what is this? Is high frequency. What is this? Is 1.5 into 10 to the power 3. What about this? 1.5 into 10 to the power 6. So if you consider it is 1.5, that is 1.5 into 10 to the power 3, it has 3 zeros. So after this third zero I am keeping this point, so it is 1500 hertz. So converting this to hertz I am getting this. What about this? 1.5 into 10 to the power 6 is 1506 values 5, and after this first value, because 0.5 I am keeping this here and discarding it. So this is the actual hertz. So coming to the antenna height, what is the velocity of light? This is general case, 3 into 10 to the power 8. Now you substitute in this equation for this first half and the second half and compare. So what is the antenna height for the first case? It is nothing but 3 into 10 to the power 8 divided by 2 into 1500. So here what is the value you get? So this is 3 into 10 to the power 8. It has 8 zeros, as well as it becomes, here it is 300. So 3000, right? 3000. So cancelling it, you will get 3 zeros get cancelled, you will get 5 zeros at the top. So it get 1, 2, 3, 4, 5. So this is what, sorry, not 3 3 gets cancelled, it becomes 1, right? So this is the antenna height. In terms of height means in terms of meters. So converting this, you will get, it is a 100 kilometer. Converting this 3 zeros, you will get meters in kilometers. The first antenna height is 100 kilometer. Now coming to this antenna height 2. It is 3 into 10 to the power 8 divided by 2 into 15. That is, you will get 15, 5 zeros. So this here 5 zeros get cancelled, you will get 3. So this 2 into 15 is 3, so it gets cancelled and 1. So what is the value you get is 3 zeros only, that is 1000 meters. So antenna height ensures 1000 meters, and this antenna height when the frequency is low ensures 100 kilometers. It requires 100 kilometers. So it requires, when the frequency is increased, high frequency, you require only a low, that is antenna height of very low, it is 1000 meters, whereas here it requires 100 kilometers. You could imagine 1000 meters with 100 kilometers. So erecting this antenna vertically, you could see here how much height it will be. So reducing the antenna height for effective transmission, we are going for the carrier. So this is nothing but the carrier frequency. Carrier frequency is nothing but which is a high frequency. So whenever we are using a high frequency component, modulation is involved, and this provides an easy transmission. So this is how the antenna height is determined. This can be asked in 2 marks as well, giving and frequency, and it can be asked for your exams in terms of competitive exams also. So now coming to the narrow banding. So the narrow banding, the same concept what we have studied for this antenna height will be useful here to determine the narrow banding technique. So narrow banding is nothing but there is a spectrum, right? This is a channel which uses a frequency spectrum in all ranges. So this frequency spectrum is nothing but starting from 10 to the power 1, it reaches from 10 to the power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, etc. So if I am telling this is in range of hertz. So if the signal is occupying the entire frequency range of 50 hertz to 10 kilohertz, if a message signal is being passed, so this requires the ratio of the lowest frequency to the highest frequency signal through a same antenna, right? Here there is an antenna in the channel, will be practically impossible. Will be practically impossible. Why I am saying practically impossible is because whenever this is transferred from low frequency to high frequency, it requires, it will be very much, the antenna design requires a very large wide band antenna range, right? And whenever it is from high frequency to low frequency term, it requires same concept, that is wide band antenna. So installation of this wide band antenna is very, very tedious. So by means of this modulation technique, when this kilohertz range is increased to 10 megahertz range. So previously we have practically seen how this is affecting in antenna height. So when this frequency is increased to 10 megahertz, this ratio between this lowest frequency, what is the lowest frequency is 10 to the power 10 megahertz range, that is 10 to the power 6 added with 50 hertz signal, low frequency signal, ratio is taken for 10 to the power 6 megahertz signal with 10 kilohertz signal. So 10 into 10 power 3 into 1, that is again 110, which is 10 to the power 4. So calculating this, it reaches 1 divided by 1.101, so which is nearly an unity, that is 1. So there is no change when the frequency is increased for this by means of a modulation technique. So this, by means of this narrow banding, the modulation part, the modulation converts this wide band range, this wide band signal, to a narrow band signal. Hence, this narrow banding is very, very important in terms of channel in initializing and signal transmission. So this is achieved by means of this modulation. So next, its application in multiplexing. So let me explain what is multiplexing first. Multiplexing is nothing but converting this is a source example, and this is a channel, and this is your destination. Say this source, we can say there are n number of sources, right? Here also n number of destinations. So here from a source, if it is passing through this channel, as I said, there will be another source interfering the same signal, that is, it will be passed through the same channel to reach another destination level. So this is what we say in mobile phones when we speak to another person. Sometimes there will be a crosstalk. So some person will be talking to another person, it will be interfered by means of this signal. So how this interference, that is how this interference occurs is, if this frequency of this signal is in the range of 0.3 to 3.4 kilohertz example, and one person is having a frequency range of some 0.5 hertz, and another one is having a nearly 0.56 hertz. So what happens, these two signal having the nearly more or less same frequency will collide with each other, making an interference. That is called as interference. So why this is happening is because it uses multiplexing concept. That is, multiplexing is nothing but by means of this multiplexing, this can be avoided, because when this multiplexing technique by means of using modulation is enhanced, this frequency can be sent in one interval and this frequency can be sent in another interval. So this can be divided, modulation and multiplexing can be divided in terms of time, in terms of frequency, and in terms of space. Further, it is divided in terms of wavelength, etc. Right? This is when it is divided in terms of time, it is called as time division multiplexing. When it is divided in terms of frequency, it is called as frequency division multiplexing. In terms of space, it is space division multiplexing, and wavelength division multiplexing, WDM, TDM, FDM, SDM, etc. So by means of this modulation technique, this multiplexing can be enhanced to provide a signal transmission over the same channel without any interference. Hence, this modulation is very, very important in terms of multiplexing. So now coming to the point how this modulation helps in overcoming the equipment limitations. So when this modulation, that is transmission of signal, is taking place over this channel again, it involves some source to the destination again, right? It involves this signal processing technique. So here the signal is getting processed and it involves various equipments, right? So this various equipments which is involved will be complex in nature, right? It will be complex in nature, and it is to be operated at some fixed frequency range. So in order to avoid signal loss, it is to be operated in some fixed frequency range. So this will be very complex in terms of using more number of equipments. In order to reduce this or equipment to be used, so with the least number of equipments we cannot achieve this signal processing technique. It can be achieved only by means of frequency translation. So this fixed frequency should be converted to the other form of frequency range, which is to be translated from the source to destination. This is possible only by means of this modulation technique. Hence, to overcome the equipment limitations, which is to be operated at some fixed frequency range, to be converted to other frequency form by means of this frequency translation, needs modulation techniques. Next application is modulation in frequency assignment. How this modulation helps in frequency assignment is, as I said, this channel which is having different range of frequencies, it has different range of frequency, which is called as frequency spectrum. That is different range of frequencies. So from source to destination, right? So this frequency spectrum should be allocated to different application levels in terms of some bands. So this is the frequency assignment technique, which is used as for a different applications. Let me say it is for a TV station or for a radio station, right? That is a broadcasting channels, right? So you could see the best example here is the radio stations. You might have heard about the radio stations which is operating at example, say Rainbow FM. It is 106.3 hertz, right? And about Suryan FM, it is 103 something hertz, right? So how this frequency band is allocated, that is this is called as frequency assignment. So when you tune to a particular, the receiver, you are the receiver, right? This is the source. They are broadcasting over this spectrum and you are the receiver, and if you tune the radio to the particular frequency from nearing point from 102, if you are tuning to 103 level, you will exactly hear this 103 Suryan FM. This is what the frequency assignment is. So this is achieved only by means of this modulation. So next application here is to reduce the noise and interferences. So as I said again, this communication channel from the source to the destination is involved with the presence of noise. So this is the channel, this is the air, medium of air. Imagine you are the source and somebody is the receiver. Your ex-friend is your receiver, any friend that is your receiver. If you are talking over a phone, so if there is an interference in the signal level, and he is not properly hearing the voice, then the signal quality will be very poor, which will reduce the effect of receiving the signal, that is receiving the transmitted signal as such. So in order to reduce this noise and interference, if the low frequency signal is carried by means of a carrier signal, which is a high frequency signal, and by means of using proper modulation technique, the effect of this noise and interference can be reduced. This is what they have explained for this, to reduce noise and interferences. So this noise and interference can be reduced by means of using proper modulation techniques. So when we go for a mobile communication, it uses a different modulation technique. When you go for a radio broadcasting system, it uses a different modulation techniques. So modulation is either a way where a signal is transmitted from a source to destination. It plays a major role in signal transmission. Hence, let me explain a short recap of today's class. So today we started with what is communication and how our life has transferred with the different gadgets we are using in our day-to-day life for communication means. With the basic block I have explained, and what is the different types of communication system, an overview is seen. And finally we started with modulation. What is modulation? Definition part. And what is the need for modulation part? We have seen about for easy transmission where the antenna height plays a major role. And next second one, narrow banding techniques, how the wideband antenna installation can be reduced to a narrow banding technique by means of this modulation. Next is multiplexing, when different types of channels is transmitted over the same channel. This multiplexing plays a major role, and hence modulation is used to achieve this multiplexing. Then to overcome the equipment limitations, in order to match the equipment frequency level with that of the frequency which is carried from source to destination, for frequency assignment for different application purposes, either it is a video broadcasting or a radio broadcasting services, this frequency assignment is very important, and to reduce noise and interferences finally. So how this noise and interference is reduced is by means of using proper modulation techniques. Hope this class will be useful to you, and I hope now you will be able to tell what is definition for communication, what is the definition for modulation, and what are the need for modulation techniques. These are the 3 important 2-mark questions which can be asked from this today's session. Thank you for watching my video.